Today we will be solving some selected questions from October 2025. So let's move on to the MCQ section. We move on to question number 3. Question number 3, it says, what happens to the color of the equilibrium mixture when a catalyst is added? Now it says it exists in equilibrium with the other, okay. Now it says what happens if we add a catalyst. Now if we add a catalyst to this mixture, what's going to happen when we add a mixture to an equilibrium mixture? The position of equilibrium doesn't change at all. The position of equilibrium doesn't shift anywhere. The position of equilibrium doesn't shift at all. Because if you add a catalyst, the equilibrium position is not affected, and that is why there won't be any color change, right? So the answer to question number 3 would be D. That there is no change because the catalyst doesn't affect the position of the equilibrium. Then we move on to question number 6. It says, which line on the sketch graph shows the trend in boiling temperature of the hydrides of the elements in group 6? In the class, we studied a similar trend in the boiling temperature of the group 7. And group 7 and group 6 have similar trends in the boiling temperature. For example, if you look at the group 7 boiling temperature of the group 7 hydrides, it's hydrogen fluoride, then we have hydrogen chloride, then we have HBr, and then we have HI. So the trend in the boiling temperature looks like this, right? So if you, and the group 6, they have a similar trend. In group 6, instead of HF, there will be water. It will have the highest boiling temperature because it has hydrogen bonds. And in place of HCl, there will be hydrogen sulfide, right? So the trend that matches here is this trend. This is the trend. This is the trend that matches. So your answer would be P. So basically we compared the trend with group 7 hydrides. So group 7 hydrides and group 6 hydrides, they have the same trend. Then we move on to question number 7. Question number 7, it says approximate percentage of water in the mixture by the number of moles. So what you need to do is, you need to find the number of moles of both. You need to find the moles of water. Moles of water will be 36 divided by 18, which is 2. You need to find the moles of ethanol, which is 46 divided by 46, which is 1. Right? So 18 is the molar mass of water and 46 is the molar mass of ethanol. So by dividing the masses by the respective molar masses, it gives you the number of moles, right? Now you have to find the percentage of water in terms of moles. So percentage of water will be equals to moles of water divided by total moles is 2 plus 1 multiplied by 100 gives you 66.7% or 67%. So A will be the answer. All right. Then we move on to question number 8. It says 20 cm cube, 2.0 mole per dengue hydrogen peroxide completely decomposes at room temperature and pressure. What volume of oxygen is produced here? Okay. So we know the moles and we know the concentration and the volume of hydrogen peroxide. So what we do is we find the moles of hydrogen peroxide, which is 2 into 20 into 10 to the power minus 3. Concentration multiplied by volume, 2 into 20 into 10 to the power minus 3, right? Concentration multiplied by volume. So from here we get the number of moles, which is 0.04. I think it's 0.04. Right? Let me calculate. 2 into 20 divided by 1000. Yeah, 0.04. So the mole ratio of hydrogen peroxide to oxygen is 2:1. So you find the moles of oxygen, which is half into 0.04. divided by 2 gives you 0.02. Then you find the volume of oxygen, which is 0.02, multiplied by molar volume is 24 times 24 gives you 0.48 cubic decimeters. All right, so we found the number of moles of oxygen, then we multiplied the number of moles of oxygen by the molar volume of oxygen, giving the volume of oxygen that is produced here. Then we move on to question number 10. Question number 10 says 23 grams of ethanol is oxidized by a solution of 0.1 mol per dm cube dichromate. Which expression shows the minimum volume of this solution needed to oxidize all the ethanol as shown in the equation? Okay, so you have to find the volume of this solution required. Okay, so initially you need to find the moles of ethanol. Moles of ethanol. So that will be mass divided by the molar mass. Molar mass is 46. So the number of moles of ethanol comes out to be half, or 0.5. Then you find the moles of the dichromate required, Cr2O72 minus moles of dichromate required. See the mole ratio of ethanol and dichromate. The mole ratio is 3:2, right? So if you want to find the moles of dichromate, this would be 2 by 3 times 0.5. Moles of the dichromate would be 2 by 3 times 0.5, right? Then you calculate. See, once we get the moles of the dichromate, we know the concentration of the dichromate, right? Now, if you want to find the volume, you have to divide by 0.1. So therefore, volume of dichromate required will be equal to so this would be moles divided by concentration. Mole is 2 by 3, it is 0.5 divided by concentration. Concentration is what? 0.1, right? So if you calculate this would be 0.5 times 2 by 3 times 10. So if you reciprocal 0.1, right? So 1 divided by 0.1 is 10, right? So that's what they have written here. So that, I think that was the confusion. Where this 10 come from? Basically, you divided by 0.1. So if you divide 1 by 0.1, this equals 10, right? Okay. So we move to the next question, which is question number 12. It says the best estimate. You have to find the best estimate for the value of the rate at 4 minutes. At 4 minutes, what you can do is at 4 minutes you draw a tangent at 4 minutes, right? You go to a time t equal to 4 minutes. You draw a tangent at 4 minutes. So if you draw a tangent at 4 minutes, approximate best estimate will be 1.2 divided by 8, right? Since it's just an estimation, so you write 1.2 divided by 8. So that's del y, 0 to 1.2, that's del y. And 0 to 8 is del x. So if you divide 1.2 divided by 8, 1.2 divided by 8 is 0.15. So D is your answer, yeah. So this is an estimated answer, right? 0.15, because it was not actually 1.2. This was not actually 8, right? And we couldn't read because the graduations aren't there. So that is why we are just finding an estimate. The estimated value is 0.15. Then we move on to question number 13. It says, which test would not enable a chemistry student to distinguish between ethanol and ethanol? See, adding sodium carbonate solution to each liquid. Sodium carbonate does not react with any one of them. Carbonate doesn't react with ethanol, it doesn't react with ethanol. So you cannot distinguish between them by adding sodium carbonate. If you add sodium carbonate, ethanol will not react. If you add ethanol, it will not react with sodium carbonate. None of them reacts with sodium carbonate. How would I know which one of them is present? It's not possible, right? Then we move on to question number 14. Question number 14, it says, which of the statements about the CO bonds found in aldehydes and ketones are correct? It says the CO bond is shorter than a CO double bond is shorter than a single bond. Yeah, a double bond is always shorter than a single bond. Yeah, always. Because double bonds have both sigma and pi. So double bond will always and always be shorter than a sigma bond. Right? Or a single bond. It says CO bond consists of 2 pi bonds. Wrong statement. This is a really wrong statement. As a double bond consists of a sigma bond and a pi bond. The CO bond consists of 4 shared electrons. Correct. Any double bond will consist of 4 shared electrons. Right. So the correct statements are 1 and 3. So your answer would be B. It's a very easy question because it is very clear that the statement number 2 is wrong. A double bond cannot have 2 pi bonds. It will always have 1 sigma bond and 1 pi bond. Then we move on to question number 17, which says, has a cycle is shown, okay, to calculate enthalpy change of the combustion enthalpy change of propane, which expression is equal to the enthalpy change X shown on the diagram. So you have to find the enthalpy change X, right? It's a pretty straightforward question. See, it says, see, if you look here, if you look at this arrow is towards the elements, right? The elements in the box below. The arrow is towards the elements in the box below, right? Now, if you place the arrow the other way around, doesn't this arrow represent the enthalpy change of formation of 4 moles of water? Elements, hydrogen and oxygen, when they react. See the elements, look here, the elements, hydrogen and oxygen. If you look at the elements, hydrogen and oxygen reacting, these elements, when they react, they form 4 moles of water. Hydrogen and oxygen gas, when they react, they form 4 moles of water, right? So that represents what? 4 times the formation enthalpy of water. Now, if you put the arrow the other way around, it would be minus 4 times the formation enthalpy of water. It is negative because the arrow is in the other way around. If the arrow is towards the water, this represents formation enthalpy. Since there's 4 moles, we write 4 into formation enthalpy. Now, if the arrow is in the other way around, then we put a minus sign here because the direction is reversed. So we put a minus sign here. So your answer would be C. Alright. Then we move on to question number 18. It says, which compound will produce a mass spectrum with a measured peak at m by z equal to 31? If you remember, I asked you to memorize some of the m by z values. Memorizing some m by z values makes it easier for you to figure out that which one of the compounds contain what fragments, or it's easy to identify the compound. So m by z equal to 31. 31 is equivalent to, as we studied in the class, 31 is equivalent to CH2OH plus 1. That's m by z equal to 31, CH2OH plus 1. So you look for CH2OH plus 1. It's present in A only. B, C, D don't have CH2OH plus 1. So therefore answer would be A. Alright. Okay, now we move to section B.